thing that we should talk about is we should talk about the network helper. This is the code that's provided that enables your client to send information to the game agent via REST interface calls. But rather than having you construct the network objects, we'll just treat it like we did in the GPS drawing assignments, so that you can just make a method call and then that information will be transported for you using the network helper. So if we go to the Unity client, we can see that I have a game object here called myNetworkHelper, and the only thing associated with it is a script called myNetworkHelper script. If we open that, we can walk through it here and see everything that we've got alongside. So now the key things to note are that if we just look on the right side here, we can see that we have several methods that are associated with the tower. There's several methods associated with the bomb, a couple things associated with the code, and the game state and the leaderboard. So now over here in the code itself, we can see that we're including the mini.json file. The mini.json file is provided for you as well. That's a script that needs to be in your assets directory in order for this to work. We'll check that into GitHub in a second. You can get it via GitHub. And so what we see here at the top of our class is called myNetworkHelper. That's the name of the class, it's the name of the file, and it matches the name of the game object. The first thing we've got is the URL to which we're sending our commands. You shouldn't have to change this, but this is the name of the server and the port that is open on the server that is running the game engine. So that's up right now. The next thing we have is a class that's used to manage points, and this is pretty straightforward. All it does is it encapsulates a latitude and longitude and altitude. All right, then the next thing we see are some private variables, the tower point and the bomb point. Now these are 2 points that this network helper keeps internally that are hidden from the client, the rest of the client, which is where it saves the location that it's going to upload later. So the idea is that you go into the park and you have your location, which is coming from GPS. That doesn't require network. You go into the park, you can look at the game world because you've downloaded the game world, you know where you are, and you know how the phone is oriented. None of that requires network. And when you're at the place where you want to place your tower, you hit a button and you store your location. What that's doing is it's storing, if you do that and you connect the pieces correctly, what that will do is it will store that location here on the tower point until you're ready to upload it. Okay, so the function that you store a tower point on is just called the build tower point, or build a tower point. You pass it a latitude, a longitude, and an altitude, and internally this class is just going to keep it in a private variable here. If you're interested to know what the current point that is stored is, you can check to see if it's set by calling isTowerSet. You can check to see what its latitude is, and its longitude is, and its altitude is through these public calls that can be accessed in your GUI component. Okay, so just like that, just like the tower, there's a parallel set of methods for dropping the bomb. So the bomb point has a latitude, longitude, and altitude, but by calling that function and by calling the tower function, all you're doing is storing the point locally in your client for future use. If you want to check within your client, if you've stored a point, you can check is bomb set, and if it is, then you can check the latitude, longitude, and altitude that you have if you need that for your GUI. Now when the person playing the game gets to a point where there's network, then at some point you want to have the client in the GUI enable them to upload that point. And when it comes time to upload that point, you call this public method upload tower point. You pass it the name of the game world that you're playing in, the password for the game world, the name of the player that's playing, the password for that player, and then this funny thing, which is the way C# does callbacks. And what this syntax means is that callback has to be the name of a function that takes nothing. It's the name of a function that takes a dictionary of a string and an object as its one incoming parameter and returns nothing. Right? So this is a function that you're going to write, and you're going to pass that function as a parameter to this upload tower point. So what upload tower point is going to do is it's going to take the tower point that's been previously saved, if there has been one saved, and it's going to pass it to the game engine, and it's going to wait for a request, but it's going to wait for the request asynchronously. So you can upload that point, and your client is going to break off a component that's going to try and upload the point. If it's successful, and when it's successful, it will call your callback to let you know that that process has been completed. Okay. Same thing happens here in the upload bomb. If you have uploaded a bomb point previously, then this code will upload it to the game engine and start a separate process for waiting for that request to come back. You also have to pass a callback function here. It can be the same callback or it can be a different callback, depending on what you want to do when the bomb has finished being uploaded. Finally, there's a very parallel function for uploading a code, or the power-up code. For the power-up code, you need a world name, a world password, a player name, and a player password, the code that you want to upload, and then the callback function for the function that you want to have executed when this is done. So this is the code that if you have passed a code, this will upload it to your game engine. Okay, finally, something that we're going to talk about in depth in the next chunk of tutorial is refresh game state. And what this does is when you pass it your world name, your world password, your player name, and your player password, and give it a callback, it'll go out and it will request the state of the world from the game engine and pass the state of the world to that callback function. And what the state of the world looks like is documented here in this bit of JSON. If everything's okay with your request, you'll get false for an error. You get a dictionary of data, which consists of a result, an origin X and origin Y, step Y meters, step X meters, and the number of splits in the X and Y direction. So to break this down, what this means is that the origin of the game world is at this location, so this is the southwest corner of the world, and the world has been divided up into grids, and there are 100 grid elements in the X direction and 100 grid elements in the Y direction. That corresponds to longitude and latitude, and that in the real world, each step in the Y direction is 2.878 meters, and each step in the Y direction is 2.85 meters. For each one of these 100 by 100, for each element in this 100 by 100 grid, there is an element listed here in the tower. It's a little dictionary which says who owns the, if there is a tower present, it's either true or it's unknown because you can only see your towers. The index of which grid cell we're talking about with this data. Land claim, which doesn't really have to be used, but it is how strongly the person who owns the land owns it. And so the landowner here would be you if you had a tower that had claimed the land, but barbarian is who owns the land when it hasn't been claimed by anyone. If there's a bomb on that location, then bomb will be true, otherwise it will be unknown. And finally, the altitude of this position is listed here, and in this case we don't know it, so it comes back as not a number. So you can see that the first one here is 0, 0, and the last one is 99, and you can use those to help render your world. The next function that you can call in the network helper is a request for a leaderboard. And to get the leaderboard, you pass the world name and world password, but you don't need a player name, and a callback that will receive the leaderboard when it arrives. And then here's the code that executes that. Finally, these last private functions at the bottom of the network helper are all of the code that's used internally in order to execute that callback to your function. So the last thing that I want to do is I want to show you what it looks like for one of these callbacks to be passed, say for example, to the request leaderboard. So when I request the leaderboard in my GUI function, let's see, hang on a sec. Let's see. Let me find that for you.